So this problem here, which is at the bottom of 2.7, gives us that Q is the midpoint of PR, Q is midpoint of this line segment, and then R is midpoint of QS. R is the midpoint of this line segment here. We need to prove PR is equal to QS. So what is the strategy, right? Well, this document here, How to Write a Proof, tells you the strategy when it comes to the segment proofs, right, which is 2.7. And the strategy starts right here on statement 3. If there's any congruent statements, convert them to equations using definition of congruent segments. First step. Second step, if midpoint is given, then use the definition of midpoint to create an equation. Third step, right, number 5, is to look at the figure, and if segment addition postulate, if you have 3 points on a line, then you can use segment addition postulate to create another equation. And segment addition postulate lets you say first part of the segment plus second part of the segment equals the whole segment. And now you have all the equations you need, and then you use substitution to move your way to the proof. So that's the strategy we're going to use here on this problem. They give us Q as midpoint of PR. Okay, and so we now look at our proof cheat sheet and we look for the definition of midpoint. Right here is our proof cheat sheet, right? And we're looking here, definition of midpoint. So B is the midpoint of AC, then that means the left side is equal to the right side. That's the definition of midpoint. So we're going to go ahead and start by saying number 1, write down the given. So that's Q is midpoint of PR, and then we also have the other given, R is midpoint of QS. So number 1 is going to be given, and so what's the next step, right? We wrote down the givens. Well, it's to turn any congruency statements into equations. Looking here at the givens, we don't have any congruency statements, so we skip that step. Right? Next step is if we have any midpoints, you turn those into equations. So if Q is the midpoint of PR, that means this left side is equal to the right side. Okay? So then our equation here is going to be PQ is equal to QR. And that's going to be definition of midpoint. Our other equation is going to be R is the midpoint of QS. So R is midpoint of QS. What does that mean? That means this side is equal to that side. So we can say QR is equal to RS. QR equal to RS. Number 2 is def of midpoint. Okay, so we did that. Now what's the third step, right? Well, in our How to Write a Proof series of steps, it's to use the segment addition postulate to create more equations. So now we're looking here at the figure and we're saying, do we have 3 points on a line? And yes, we do have 3 points on a line, right? We have those 3 points on the line, P, Q, and R. So we're going to go ahead and create an equation using the segment addition postulate. So we got 3 is going to be the first part of the segment is PQ plus QR is equal to PR. Right? First part plus the second part equals the entire segment, PR. That's my first equation. However, in this figure we have 4 points on a line. So that means we could do segment addition postulate on that side, and then we can do segment addition postulate on that side with those 3 points, Q, R, and S. So let's go ahead and do that. We got QR plus RS is equal to QS. So number 3 is going to be seg adpos. Okay, so we finished all our steps, right? We turned any congruency statements. We don't have any congruency statements. We took midpoints and we turned them into our equations. Then we looked at our figure and we ran seg adpos on the figure to create more equations. Last step is to substitute to get to that proof right there. So how can we substitute to get to that proof? Well, let's see, what can we do? We can take this QR here, right? QR is equal to PQ. So that means anywhere we see PQ, we could put QR. And I see a PQ right there. And again, you can't substitute into the same equation. You need to substitute into a different equation. So I'm taking this QR and I'm putting it right there instead of the PQ. So I'm going to rewrite that as QR plus QR is equal to PR. Okay. Now I'm going to take this QR it's equal to RS. That means anywhere I see RS, I can put QR. And so I see RS, it's right there. So I'm going to take this QR and I'm going to put it right there instead of RS. So it's QR plus QR is equal to QS. Okay, so now if you notice, we have QR plus QR equals PR. We have QR plus QR equals QS. So PR and QS both equal now the same expression, right? So that means I could take this PR and I could put it in the place where I see QR plus QR. So I'm taking this PR and I'm going to put it right over here in the place of QR plus QR, substitution. So I want to say now PR is equal to QS, and that's my proof statement. All right? So we substituted our way to the proof statement. Let me go ahead and say this is 4 and this is 5. Right? So 4 is going to be substitution, and 5 is also going to be substitution. Okay? And so that's how we did this first problem here.